Light blue problem. Vera studies the extinction of the bear population of Siberia over time. Shh. The following function gives the number of bears years since Vera started tracking it. Now I like understanding everything I'm working on. So let's understand it really quick. What's my vertical axis going to be on this one? It looks like the number of bears, right? It's B of T. So this would be bears. What would be my x-axis? That's right. It's T. What's my time? Years. Okay. So T is in years. B is number of bears. Okay. Now, if you were intuitive and you had a brain and you're trying to find shortcuts, you might have done this. You might have said this, which doesn't work all the time, but I think it's very clever. You might have said, Vera studies the extinction of bear population. So if they're being extinct, wouldn't the rate be negative? Wouldn't it? It would. So then you'd be like, oh, it's got to be this one or this one, right? Now what's the difference between those two? The difference is the units. And so which of these units is correct? Well, if you remember, hopefully you do, if you had the slope of this, the units for the slope would be bears over what? Over years, right? Years. So which one of these is bears over years? Oh, it's D. So I would think that D would be my answer. But I wouldn't trust it. And the reason why I wouldn't trust it is, what if that 1 year there was a slight uptick in bear population and then it started decreasing again after that? Because this is instantaneous rate of change. So let's go ahead and find it. And we'll take more shortcuts, don't worry. But what I'm about to do is the most surefire way to make sure you have this right. It says, what is the instantaneous rate of change of the number of bears after 2 years? So what you would do is you would take B prime, because that'll find the instantaneous rate, and you're going to plug into that 2 years. Okay, but before I do that, I gotta find what B prime is. So let's go up here and find B prime. B prime of T would equal, I see a scalar, so I'm going to ignore this guy, okay? I'm just going to write him out, 2190. And then I have to take the derivative of this guy, the E. So first I get E raised to the negative 0. What is that, a 3? 3t. And then I have to multiply that by the derivative of negative 0.e or 0.3t. What's the derivative of that? Let's see. Derivative of that would be negative 0.3. Oh, that's not so bad. And now I just got to plug the 2 into it. So if I plug the 2 into it, this is what it would look like. We have 2190. And then we have E raised to negative 0.3 times 2. And then I have a negative 0.3. Okay. All right. Do you guys know what that negative does? The only way I can do this now without using a calculator is knowing what this graph right here, e to negative 0.3t, looks like. So here's a quick reminder, guys. If I had just e to the x, my graph would look like this. But if I throw a negative onto that x, so negative 0.3 times x on the e, that would flip the function, right? It would flip it to this way. Actually, these should be intersecting the same point. It would flip it because it changes the signs of the x's. But then, because it says 0.3, that also does something to the graph. And I think all it does is it's dividing it by 3. It just shrinks it a little bit. So let's look at negative 2. Is this a positive number? In fact, all of them are positive, right? All the numbers on this green line are positive. So that means this is a positive number. This is a negative number. And this right here is a positive number. If you go positive times a positive times a negative, do we get a negative?
Yes.
Yeah. Now, if I got a positive, then I would be like, oh, shoot, this one's not the right answer. It's this one. Without having to chug it out and do all the math. But it is negative, so it looks like our first thought was correct.